and then we'll see what's up. Cool? All right, so here we go. The almighty chain rule. You guys ready? So we know how to take the derivative of sine x, and we know how to take the derivative of x squared minus 4. The derivative of sine x is just cosine x. The derivative of x squared minus 4 is just 2x, right? But how do we take a derivative like sine of x squared minus 4? Well, no, this is not a product. This is sine of an argument. So this is not product. Like sine does not go by itself. This on the inside is part of the sine. So whenever you get something like this, you got to do something called the chain rule. And it's just a rule like everything else. So it's easy to follow a rule. If you want to know the proof of the rule, that's going to take some time. So if you want to do a proof of this, come by or just Google proof of chain rule, Khan Academy. I think I've seen a proof on Khan Academy, and I've seen plenty of proofs on YouTube. Some are good, some are not. Look for the ones that has the highest rating. So yeah, if you want to see a proof, come by, we can do it. But this is just a rule, and we're just going to be applying the chain rule to find derivatives. Does that make sense? So, okay. All right. So look at this function. I have an equation, y equals 6x minus 10, and I broke it up. You would never do this in real life, but we broke it up into that so we can see how the chain rule works. So before I find, now check it out. It says it is a composite function of y equals 2u, where u would equal 3x minus 5. Does that make sense to you guys? Well, I wrote it right here. I didn't see it initially. How are the derivatives of these three functions related? Okay, well, let's see. Let's just do, I'm going to write y equals 6x minus 10. And instead of writing y prime, I'm going to write it like this. I'm taking the derivative of y with respect to x. What's the derivative of 6x minus 10? Perfect, that's it. Done. Cool or not cool? All right, now let's look at the y equals 2u. I'm going to write y equals 2u. Now, I'm going to take the derivative of y, but I'm not taking the derivative of y with respect to x this time. I'm taking it with respect to what letter? So I'm going to write dy over du is equal to 2. Done. Are we still okay? Now, I'm going to write, here on the side, I'm going to write u equals 3x minus 5. You can already imagine. I'm going to take the derivative of u, but with respect to what? So I'm going to write du dx equals 3. Hopefully you notice.
Oh, yeah. Okay.
Do you see what's going on here? So dy dx is nothing more than dy du times du dx. Do you see how the du's are going to cancel right there anyways? And you still get dy dx? That is really chain rule. See? dy du is 2. And du dx is 3, and we still get that 6 value. Cool or not cool? No? They're telling me, well, do you agree that the derivative of this is 6? Okay, look what I did here. I took the derivative of y with respect to u, and I took the derivative of u with respect to x. If you multiply 2 and 3, do you get that same value of 6? Yeah. That's what they're trying to say. Cool or not cool? Now, what did we just do? So let's think about what we just did. So really what we did here, this is like taking a derivative of the outside. Maybe I should have mentioned that yet. Okay, let's not mention that yet. Until this one right here. Okay, so the polynomial 9x to the 4th plus 6x squared plus 1 can be written as 3x squared plus 1 with a square on the outside. And just for kicks, this is just because I know our algebra sometimes, just for kicks, let's expand this just to make sure. 3x squared times 3x squared, 9x to the 4th. I'm just expanding it. 3x squared times 1 is 3x squared, but you're going to have 2 of those, so I'm going to write plus 6x squared. And then 1 times 1, 1. So notice that 9x to the 4th plus 6x squared plus 1 is just this guy right here. Cool or not cool? Okay. And then I tell you it's a composite function of y equals u squared, where u equals 3x squared plus 1. Are we still okay? I'm going to do the same thing that I just did a little while ago. If I just told you, would you ever do this? Would you ever do chain rule to take the derivative of this? No, you would just use power rule. All we're doing right now is confirming chain rule. Cool? So if I just told you, what's the derivative of this right here? you would tell me, I'm going to write it like this, guys. I'm going to write y equals 9x to the 4th plus 6x squared plus 1. And I'm going to write dy dx, because I'm taking the derivative of y with respect to x, is equal to, now what's the derivative of that? 36x cubed plus 12x. Done, right? Okay, so now I'm going to write y equals u squared, and I'm taking the derivative of y with respect to u. What is that? 2 and u. Yeah, that u doesn't go away, but we can plug it in a little bit. And u equals 3x squared plus 1. So I'm taking the derivative of u with respect to x. So what's the derivative of that? Okay, so let's see if we still have this as a true statement. So I'm just doing this. So I'm doing, let's see, dy du times du dx equals dy du was 2u times 6x. Are we still okay? All right, 6 times 2 is 12, and I still have a u and an x. And if you wanted to replace the letter u, let's say you wanted everything in terms of x. What is u again? So I'm going to replace that. So I'm going to write the x in front actually. 12x parenthesis and then 3x squared plus 1. Have I confused anyone? Okay, that's your u right there. Now let's distribute and see if we get this guy right there. 12x times 3x squared. There we go. 12x times 1. There you go. Look at that. Did we get the same? Okay. So let me tell you what's happening. You probably already see what's happening. So this dy du is like derivative of outside. And we'll talk about what outside means in a little bit. And this du dx is derivative of inside. And I probably should add, when it says derivative of outside, I probably should add in the little quotes here, leave inside alone. And you'll see what I'm talking about. Chavez, I have no idea what you're talking about. Okay, so you know what? Let's just do it right now. Don't write anything down, just listen. So y equals parenthesis 3x squared plus 1, close it to the what power? 2. Don't write this down, just listen. So I'm just going by the notes. So this says dy dx equals derivative of outside, and then in green it says leave inside alone. And then that du dx is derivative of inside. So what is outside? Well, outside is everything outside that parentheses, right? And then what is inside? Inside is that 3x squared plus 1. Don't write anything down, just don't worry. So if I were to tell you y equals 2x, or sorry, not 2x, y equals x squared, what's the derivative of x squared? 2x. Yeah. So it's the same deal. You hold, when I say take the derivative of the outside, you hold the 3x squared plus 1 like it was a variable. So you're going to go dy dx is equal to, bring the 2 to the front, leave the inside alone, 3x squared plus 1, subtract 1 from that power, 1, times the derivative of the inside. What's the derivative of 3x squared plus 1? And that is your chain rule. See? That turns to 12x times 3x squared plus 1, which is exactly what we had up here. See? And then that gets you that. Does that make sense? Oh, it's all going to be the same. We're going to do a whole bunch. What you just did, and I do like this. This is a composite function. Chavez, what does that mean? It means this. They should have probably put that one first. So check it out. F of gx. So this is why we wanted M&Ms. If we want to take the derivative of this, let me put this in brackets. D dx, and it's in there, so you don't have to unravel it. But here it is for good notes. Ready? You take the derivative of the outside. So I'm going to write f prime. We leave the inside alone, g of x. And we take the derivative of the inside, g prime of x. And the definition is in there, I think, somewhere. Oh, look, it's right there. What do you guys think? And don't worry, we're going to do this over and over and over until you got it cold. Cool? Always work from the outside in. Are we still okay, guys? All right, so here we go. An object moves along the x-axis so that its position anytime t is greater than or equal to 0 is given by, and they tell you that equation, find the velocity of the object that is a function of time. How do I get velocity from position? So we're going to take starts with the letter D. We're going to take a derivative. We know that, right? Okay, so here we go. V of t is equal to x prime of t. That means derivative. Which is equal to, so what's considered outside? That cosine is outside and the t squared plus 1 is inside. You guys ready? What's the derivative of cosine? So we're going to write negative sine, and it's an argument, so you got to leave the t squared plus 1 by itself anyways, so double whammy. Am I done taking a derivative? No. Now times the derivative of the inside, because it's not a linear term, so we got to take a derivative. What's the derivative of t squared plus 1? 2t. That's it. If you want to make it pretty, you can write v of t is equal to negative 2t sine of t squared plus 1. How do we feel? Yeah, it's not bad, right? Don't worry, we're going to do complicated ones. And here's me typing this morning. Let's have some M&M's. Sorry I didn't bring any. Rain check for tacos for the future. Put me down for tacos on exam day. Tacos on exam day. To make things easy, we're just going to do potato, egg, and bean cheese. Are you guys okay with those two? All right. So there it is. Potato, egg, and bean and cheese. What, you want like chorizo egg? All right. You convinced me. Chorizo egg. Okay, no more. Just those three. All right. Here we go. You guys ready? And look, I put it in words here. In words, differentiate the outside function of f and evaluate it at the inside function g of x left. Okay. And then it says here, you'll hear me say, take the derivative of the outside, leave the inside alone, then take the derivative of the inside. And that's common. It's common for, I didn't put my quotes there, end quotes. It's very common for someone to be saying that. If you go to Khan Academy, I think they're going to say that word for word, pretty much because it's universal. It's the same rule. Cool or not cool? All right, so here we go. You guys ready? I think we already, okay, that should have been down there, man. What example? What? Oh, we just did example 3 with chain rule. Darn it, I was supposed to do example 3 with this route, but I think we already got enough experience. That's fine. Put awkward emoji there. All right, here we go. Example 4. Differentiate sine of x squared plus x with respect to x. So here's how you write that first. You're going to write d dx, and in parentheses you're going to put what you're trying to take a derivative of. Sine of x squared plus x. If you want to call that y, that's fine. And then you could have gone y prime. So I'm taking the derivative of that. Equals, so first start with the outside. What's the derivative of sine x? Cosine. Leave the argument alone. It's x squared plus x. And then I'm going to go times the derivative of the inside. What's the derivative of x squared plus x? Done. That's it. Make sure to use parentheses. Maybe I write the 2x plus 1 in the front. And you can see why parentheses are super important. If you do not write the parentheses in the 2x plus 1, it would be counted wrong. Because then it's like having the product of 1 times cosine. And it is not the product of 1 times cosine. It's a product of 2x plus 1 times cosine. Are we cool? Okay. Yeah, that's it. We're going to do a harder one. Check it out. Don't worry. But it's the same concept. It's just over and over. So look at this one, guys. You keep using the chain rule until you've gotten all the way to the peanut in an M&M, right? Outside in, the shell, then the chocolate, then the peanut. So you keep, yeah, that's why I wanted to bring M&Ms. Yeah. So you work yourself from the outside in all the way. So here we go. It says find the derivative. So I'm going to write g prime of t equals, so you work your way from the outside in. What is the derivative of tan? Secant squared. So I'm going to write secant squared. Now, instead of writing x, I got to write the argument that they give me here. By argument, I mean stuff inside the parentheses. So I'm going to write 5 minus sine 2t close. Am I done? No. Now we're going to take the derivative of 5 minus sine 2t. So I'm going to write times, or a little dot, open parenthesis again. The derivative of 5 is 0, goes away. The derivative of sine is cosine, but there's a negative in the front, so I got to keep that. Negative cosine, keep the argument, 2t, close, close. Am I done? No, I still got the peanut. I still got another. I got another argument, the 2t. Times, what's the derivative of 2t? 2. Is there anything else? No, that's it. I've reached everything. Done. So we're going to write g prime of t equals, and I would put the 2 in the front, maybe even the negative cosine 2. So I'm going to write negative 2 cosine 2t, close, secant squared of 5 minus sine 2t, close, close. And I think there it is. I don't think I messed up with any other parentheses. Oh, there's nothing to distribute. These are arguments from all that belongs to secant or secant squared, and the 2t belongs to cosine. So there's nothing to FOIL out or distribute or multiply. Right here, like right there? Yeah, you can do that. But I would also bring the negative to the front since there's a negative there. Parentheses are super important, guys. If you don't put that parenthesis and you don't put that dot, look how it looks like. It looks like you're subtracting. And I can't tell. It happened. Oh, should I? Okay, I'll say it. It happened at least once where I was devastated, where it was not obvious that it looked like they were subtracting it, and I couldn't. Like I even sent it to the table leader, and I'm like, hey, can I give this kid a point? And it's like, it looks like he's subtracting. It doesn't look like he's multiplying. If you would have put an X or a dot or something, maybe, but we can't do anything about it now. So you gotta put those parentheses, or either that or move the negative to the very front. Yeah, because it's supposed to be a product, guys. It's not. So you're not subtracting anything. What's up?
So you don't then have a integral on the inside the 5 minus sine 2t.
Well, I already did. The derivative of 5 minus sine 2t is negative cosine 2t.
So you don't change the argument?
No, the argument, you can never change it. It just stays, right? We did. We worked our way from outside in. So what's the derivative of tan? Secant squared. So we put secant squared, and we did keep the argument that we had for tan.
But then in order to fully simplify, this is the fully simplified version.
Yes.
You don't fully.
That's it. Yeah, you don't have to do more. That's it. Because then when do you stop? Because you can keep going, because there's always an inside. So you just, once you do that inside, then do the next inside, and then once you've done the last inside, done. What's up? Will this work? They haven't been used. That's not working. All right. I thought I was going to use more space. Sorry about that white space there. Oh, yes, finally, we got this one. I like it. I love it. Here comes you don't need a calculator. Here comes your unit circle. By the way, we're going to start doing them again, guys. The only reason why we stopped is because I stopped. But the pre-cal class just got into the unit circle. And literally what I'm going to do, just to save time, whatever quiz I give them, I'm just going to give you guys. So actually be sad for the pre-cal class because I got to think about you guys, so I got to give you guys harder questions. So they're going to get dosed with harder questions, right? Like they're going to, instead of like giving I'm going to say cosine of 11 pi over 4. And like, they're going to be like, what? And like, yeah, well, let's see, 8 pi over 4 is 2 pi. And what's the difference between 8 pi and 11 pi? That's 3 pi. So cosine 11 pi over 4. 11 pi over 4 is the terminal angle to 3 pi over 4. So 11 pi over 4, you're in quadrant 2. Like, so be sad for them, not for... Okay. Because usually I start off simple, right? Like sine pi over 6, cosine pi over 3. Like, I give nice angles. But I'm not... Okay, I'll stop. Edit that out for the YouTube fans. Okay. So here we go. Find the slope of the line tangent to the curve, y equals sine of the fifth power x, at the point where x equals pi over 3. So they don't want a tangent line, they just want the slope. How do I find slope? How do I find slope, Ms. Guerra?
You find slope with the derivative.
That's right, with the derivative. So we're going to take the derivative of this. So I'm going to rewrite this, because some of you may, I know you guys all know, but I'm going to rewrite this to make it easier. So here's how I'm going to rewrite it. Giant parenthesis, sine of the x, close it, put the power 5. Do you guys see what's going on? That's the same as the sine of the fifth of x. So here we go. I'm going to write y prime. You can write dy dx. It's all good. Take the derivative of the outside. So what is the outside? Well, everything outside the parentheses there, right? So 5, parenthesis, sine x, close it to the what power? 4. Okay, we subtracted 1. Chavez, I don't get it. Hold on. Don't worry. It's like saying, side note, it's like saying, what's the derivative of x to the 5th? 5x to the 4th. See? It's like saying that. 5, that x instead of x is sine x, and I subtract 1 from the power. Okay, am I done? No. What's the derivative of sine x? There it is. Now, I just took a derivative. I haven't done anything. I haven't answered the question. I need to figure out, I need to plug in that pi over 3. So here we go. Let's see if you know your unit circle. 5 sine pi over 3 to the 4th times cosine pi over 3. So here's my unit circle. Pi over 3 is like what degree? 60. And at 60 degrees, the x is what? The x is a half, and the y is square root of 3 over 2. Yeah. Oh, yeah. I was saying x as an x coordinate. All right. All right, let's see. So here we go. Y prime. 5. Sine of pi over 3 is to the 4th power times cosine of pi over 3. Can you do this without a calculator? Yes, yes, you can. 5 times, let's see, square root of 3 times square root of 3 times square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is 3. And 3 times 3 is 9. 2 times 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. And then all that again times 1/2. So my final answer, what's 5 times 9? 45. What's 16 times 2? No, not 30. 16 times 2? 32. There it is. Do you see how we did it, guys? No. Yeah, you can't. It stays like that. All right, here we go, guys. Chavez, this looks like quotient rule. This doesn't look like. No, it's chain rule. If you see it, you see. Remember when I told you guys, if you have a constant in the top, you can just bring up whatever you have in the bottom to make life easier for yourself. So look, I haven't taken the derivative yet. D dx, giant parenthesis. Bring up everything in the bottom. Little parenthesis, 1 minus 2x, close it to the negative 3, close my giant parenthesis. Do you guys see that?
Yeah.
Parker?
Oh, is this the exponent rule?
Yes.
Okay.
Yeah, laws of exponents. I just brought it all up. Can we do that, guys?
Yes.
All right, so now here we go. I'm going to write equals, meaning I'm taking the derivative. I'm going to bring the negative 3 to the front. Leave the inside alone. 1 minus 2x, close the power. What is the degree now? -4. Perfect. Times the derivative. Well, okay, am I done or no? No, you're not done. Times the derivative of the inside. -2. So they're probably not going to have it written like that. You're probably going to have to simplify it. So here it is simplified. -3 times -2 is, put that in the numerator, over that -4 exponent, bring it back down. 1 minus 2x, close it to the 4th power.
Wait, sorry, yeah, the -6 we
-3
counted.
times -2. How do we? Because I brought it down.
That's exponent rules.
Laws of exponents. That's the derivative. That's d dx. How do we feel, guys?
So, would we write y prime equals, or we just write?
You could write y prime if you wrote somewhere on the top that y equals 1 over 1 minus 2x to the 3rd power. But because it says d dx and I have an equal sign here, as soon as I put the equal sign here, it's telling me that I'm finding the derivative of that expression. So I would do not write y prime unless you say that equals y, and then you can say y prime. Are we okay so far?
Yes.
Okay. I think we're actually pretty close to, yeah. All right, let's see how we, this is actually from your textbook, the Demana textbook. Take 2 minutes and see if you can do question number 1 on your own. So try, if you want to chat with your partner, that's fine, but try to do it on your own, guys. Yeah, if you're done with number 1, go for it. I like number 2, actually. All right, here we go, guys. If you're already on number 2 and you already figured out number 1, go for it. You're good. dy dx equals, what's the derivative of tan? Secant squared, right? So secant squared, leave the argument alone, 4x. Am I done? Times the derivative of 4x, which is 4. So look for 4 secant squared of 4x. 4 is all over the place. How do you feel? Yeah, that's it. All right, check it out. Question number 2. Take 2 minutes. Look at the last example where we found the slope of sine or whatever it was. Okay, I'm going to go ahead and get started, guys.
Wait. Pause. Hold on. I'm almost getting there.
I'm just going to tell them to rewrite it. Until you're pros. Once you're pro, you no longer have to rewrite it. You can go right into it. But it's going to take a while for you to become a pro. It's probably going to take until Thanksgiving where you're like 100% super confident, super beast. So until you're there, anytime you see cosine squared or any other power, immediately do it like this. Immediately rewrite it and notice that's the same thing. Cool or not cool? Okay. Now, as soon as you feel super confident, you can go ahead and just start chain rule right off the bat. So here it is. Y prime or dy dx, it doesn't matter, equals, what do I do first? Bring the 2 to the front. Leave everything inside alone. Giant parenthesis, cosine x cubed plus x squared, close, close. What power? 1. If you want to put the 1 in there, that's fine. Am I done? No. Times what? Negative sign. Leave that inside alone. x cubed plus x squared, close, close. Am I done? No, I still have that argument in there. What's the derivative of x cubed plus x squared? Is there anything else? No, that's it. Now just make it pretty. Y prime equals, let's see, I see a negative right here. You probably want to put that out. And I'm going to put that in the front. And then I'm just going to write cosine x cubed plus x squared. If it had a power, I would put it immediately after the s. Sine x cubed plus x squared. And there's actually a double angle rule that we could use, but they didn't put that answer choice in there. Good thing they didn't, because that would be evil. And we look for that answer. Where is it at? Yeah. How do we feel?
Why does the negative change the sign?
Oh, it's all a product. It's this times this times this. So instead of saying like A times negative B times C, it's always better to just say negative ABC.
All right, gotcha. Thank you.
How do we feel, guys?
And how do we know when to use the chain rule? Will it just like look like this? And it will,
Yeah.
Oh yeah, that's sort of the thing. But like for this,
It will look like something that you definitely have to do chain rule. As a matter of fact, we might just look at our exams in a little bit. So here we go, guys. So in the notes, it says, suppose that the functions f and g and their derivatives have the following values at x equals 2. So these are at x equals 2 and x equals 3. So these are just values for the function f and g at certain x values and at certain x values. And I also have my derivative of f and g as well. Cool? Yeah, they're just giving us values. And it says, evaluate the derivative with respect to x for the following combinations of the given values of x. So they want the derivative of 2f of x at x equals 2. So let's use proper notation. So here we go. I'm going to write it like this. d dx of 2f of x. What's the derivative of 2f of x? Just 2 times 2 times, yeah, but right now I'm not evaluating it at any number yet. The derivative of 2f of x is just 2 f prime of x. That's what I was looking for. So I was looking for 2 times f prime of x. Yay. Thank you, Ms. Harris. So that's it. Now I'm going to evaluate it. So here it is. Now it's being evaluated. I'm going to write 2 f prime of 2. So 2f prime of 2 is 2 times, I go up here, f prime of 2 is 1/3. So my final answer is 2/3. Cool or not cool? Cool. I've also seen it done like this. You could have put a line here. The line means evaluated at, and you can write x equals 2. And then the next line, you can just write that exactly. That's if you want to be formal. Right now, we don't really care. Well, we do care about formality, but right now we're just trying to understand the basics. Cool? All right. Once we start doing free response questions and all that, we'll tell you how to format it. But for now, we're good. So here we go. I want to find the derivative of this. So I'm going to write d dx of f of x plus g of x. So the derivative of that is just f prime of x plus g prime of x. Do you guys agree? And then on the next line, I'm just evaluating f prime of 3 plus g prime of 3. So I look what f prime of 3 is. What's f prime of 3? 2 pi plus what is g prime of 3? 5. And there it is. That's it. 2 pi plus 5. Do you see what we're doing, guys? All right, let's go to the next one. What rule do I need to use on the next one?
It says evaluate the derivative. When you're writing it, you write ddx and then you put in the big parentheses what the equation that they gave you.
Yes, because this is the notation for what I'm trying to do. You know what I mean? So I'm taking the derivative of this. So when I take this derivative, what rule do I got to use? Product rule. So here we go. I like to do first times derivative of the second. I know some of you are liking the delta way. That's fine. So here it goes. First times derivative of the second plus the second derivative of the first. We're still okay? I got it. It looks correct to me. So now I can just evaluate. F of 3 g prime of 3 plus g of 3 f prime of 3 equals, and I just write what each one is. F of 3 is equal to what? 3. So yeah, you guys hook me up. 3. What's g prime of 3? 5. Plus what's g of 3? Negative 4. What's f prime of 3? 2 what? 2 pi. So my final answer is just 15 minus 8 pi. We still okay, guys? All right. This one might bleed a little, so I'm going to change the color. d dx of f of x over g of x. What rule do I got to use? Quotient. So bottom, g of x, times right to the top, f prime of x minus top, f of x times the derivative of the bottom, g prime of x, all over bottom squared. By the way, if you were putting the squared, you would put it immediately after the g or put it in parentheses. And Chavez, what are you talking about? You can either, if you don't like having parentheses, you can put the square like that, because it's understood that it's g that's being squared, or squared like that. Cool? Okay. And so check it out, guys. We use f and g just like you guys wanted us to use, right? All right. Anyways, so here we go. So now I'm just going to write what this is. So I'm going to plug in the number. I'm trying to find this at 2. So here we go. G of 2, f prime of 2 minus f of 2, g prime of 2. If you already know what's going on, you can just plug in the numbers, and you don't have to do that all over again. Equals, what's g of 2? 2. What's f prime of 2? 1/3. What is f of 2? 8. What is g prime of 2? Negative 3. Oh, man. Sorry, I'm running out of space here. So negative, can't do anything right. Negative 3. All over, what was g of 2 again? 2 squared. All right, let's see what that is. 2/3 minus plus 8, 16, 24 over 4. So I'm going to turn that 24 into 72 over 3. So I'm going to multiply this by 3 over 3. So here's what we get now. 2/3 plus 72 over 3 over 4. So my final answer is 72, 74, 74 over 12. Which reduces, unless I did something wrong. What does that reduce to? 74 over 12. 37 over 6. Cut it in half, both of them. Hopefully I didn't make any mistakes, and there it is. Alright, now we're getting into chain, finally. Look at letter E. It's a composite function. You have something inside of something, so it's a chain rule. So I'm going to write d dx of f of g of x. So, derivative of the outside, leave the inside alone, times derivative of the inside. So let's see what this looks like. F prime g of 2 close times g prime of 2 equals, so tell me, what is g of 2? 2. So f prime of 2 times g prime of 2. Really, it's 2? They should have chosen a different number. All right, no big deal. All right, what is f prime of 2? F prime. 1/3. What is g prime of 2? Negative 3. So it's looking like negative 1. Oh, no problem. You see this here, g of 2? G of 2 is, they told me, was 2. So that number goes inside the f prime.
It's just a bad number.
Yeah, because it's right in, it's f prime of whatever you have on.
So you solve that.
Yes, you solve the inside first.
So you figure out what g of 2 is, which happens to also be 2.
Yeah, I chose a bad number. I should have, when I was typing this out, I thought I was doing like super awesome, but I guess I wasn't.
so far that's okay. So
You haven't solved G prime of 2 yet, right?
I plugged in what G prime of 2 was, -3
Oh,
on the next one. Yeah. All right. Letter F. Does letter F look like another chain rule? Yes. DDX. Oh, let me choose red because blue's in the top there. DDX. And I'm going to rewrite this as f of x to the half. If you didn't want to put the 1/2, like if you didn't want to put parentheses, you can put the half immediately after the f, and then with the notation x, which means it's a function with respect to x. All right, so here we go. I'm taking a derivative, bring the half to the front, leave the inside alone, so f of x to what power now? -1/2. Am I done? No, times the derivative of the inside, so I'm going to write times f prime of x. Does that make sense?
yes.
Okay, so now let's fix this. So I'm going to put the equal sign, so I'm still here. I'm not doing anything yet. I'm just fixing it. F prime of x over 2 square root of f of x. Did I take too many shortcuts? Or yeah. I brought the f x to the -1/2 down. So that, and then it turns to f of x 1/2. If you were here for laws of exponents yesterday, anyways, so that means square root of f of x, and then that f prime of x goes to the top, and the 2, since it's 1/2, I'd put it next to the square root.
Taking the f of x to the bottom.
Yes, because of the, yes.
But, and then
And then the 2, that 2 is this 2. Cool. Do you have to do that? No, but I think it makes the life easier. So here we go. So I'm going to evaluate this at x equals 2. So let's evaluate it at x equals 2. What is f prime of 2?
1/3.
So I'm going to write 1/3 over 2 square root of, what is f of 2? 8. All right. Don't leave it like, well, if it were an AP exam or an exam with a professor and he didn't tell you any rules, he just said evaluate, you could leave it like that. Hopefully the professor, if the professor doesn't give you any rules, he should count it right. If he doesn't, you should revolt and be like, why? You didn't tell me to simplify. Unless, he's been doing it all the time. Like, I've been doing it all the time in my notes. All right, let's simplify this just so you guys can get better with arithmetic, because it's algebra that's going to mess us up, not the calculus. If we want to solve this, the square root of 8, hopefully we all know, 4 times 2 is 8, and the square root of 4 is 2. So this turns to 1/3 over 2 times 2, which is 4, square root of 2, right? And then if you want to do keep, change, flip, you can, but you can just move that 4 square root of 2 next to that 3. So then this becomes 1 over 4 times 3, 12 square root of 2. Are we still okay? All right, then I'm going to multiply the top and bottom by the square root of 2 over the square root of 2. So now here's what we have. Square root of 2 over 12 times 2, 24. And that's how you finalize it. And if you type this number, that should be the same as this number. I don't know, let's try it out. Do I have a calculator? I do. Let's just make sure. So here's my calculator. Clear. 1/3 divided by, what did I have in the denominator? 2 square root of 8. And I got 0.0589, so let's see if that's the same thing. What did I get as an answer? Square root of 2 over 24? Square root of 2 over 24. It should be, because, if it's not, then we don't know our arithmetic. It's the same. Cool, guys? All right. Let's keep going. Are you going to do quotient rule on this one? You can, but should you? No. You can, but you don't have to, guys. So here we go. I'm going to rewrite it. I'm bringing that g squared up. And I don't know why I decided to do it this way. It's correct, by the way, that notation. But I'm going to do it the way I think everyone's comfortable. So d dx, giant parenthesis, g of x, put that in parentheses, and raise it to what power? -2.
Oh, yeah, sorry.
You're good, you're good. How do we feel? All right, let's do chain rule. What am I doing? You guys tell me. -2, giant parenthesis. What do I write inside? G of x. Close parenthesis. What power? -3. Am I done? Times g prime x. Good. If you can do that, you're winning. So now we're going to rewrite it. So let me rewrite it. G looks like -2 g prime of x in the numerator. And on the bottom, it looks like g of x to what power? The third. I just brought it down. Laws of exponents. Now I'm ready to plug in. I'm plugging in what value? X equals 3. If you want to put a line next to it, that means evaluate it at. You can. You don't have to because we're not trying to be formal just yet. -2 g prime of 3 over, yeah, thank you. I'm going to put that number in a little bit. G of 3 to the third power. So -2. What is g prime of 3 again? 5? 5 over, and then what is g of 3? -4 to the third. So -10 over -4 times 4, 16, 16 times 4, -64. So that reduces to 5 over 32. Positive. How do we feel, guys? Okay. Let's keep going. Okay. This one is going to get nasty. Yeah. This one's going to get, well, not nasty as in it's going to be all over the place. You're probably going to try to write small, not too small where you can't read your own notes. Let's rewrite it. You guys ready? I'm just rewriting it. Parenthesis, f of x, close, and do this. Put a square like that. Plus g of x, close, and put a square just like that. And let me see if I can color the parentheses so you guys can see the different parentheses. All that is raised to the half. So do you see how it's going to get like ugly?
Yes.
It's because it's a triple link chain. See, because then the f of x is like f of x squared. Okay, yeah. All right, so here we go. I'm taking the derivative, so don't worry. I'm going to start slow. I'm going to write d dx of all this. I'm going to put an equal sign. So that indicates that I'm already doing my derivative because I put my statement up here, d dx of that. Are we okay with that equal sign or no?
Yes.
So what's the first thing I do? Bring that 1/2 down. Good. Giant parenthesis. Leave everything inside that blue parenthesis alone. So I guess you don't have, well, already, okay, so here we go. 1/2 f of x squared plus g of x squared. Close that giant parenthesis to what power?
Or
Negative 1/2. Is everyone okay so far? Now I'm not done. Now I got to do times derivative of that inside. 2 f of x to the power 1. Am I done with that part? Times, no. F prime of x, right? 'Cause I'm doing the derivative of this first, and then when I get to this one, I'll do that one right now. Right? So the derivative of f of x squared is 2 f of x, f prime of x. Okay. Chain rule. If they were just telling you what's the derivative of f of x squared, you would tell me 2 f of x, f prime of x.
So you're going from the outside in, but when you get to those, you're going to do outside in for each.
Yeah. Now I'm doing the derivative of the inside, but I'm just following left to right.
Because it's all multiplication, so it won't
Yeah.
matter that much. But I thought you just
I did take the derivative, but now I got to do the derivative of the inside.
No, I thought you took the derivative of the, like, I thought 2 after that was the derivative.
No, chain rule. 2 f of x times the derivative of the inside, of that inside. This is inside, miss. See? 2 f of x to the power 1 times f prime of x. Chain rule. If you were to do, side note,
It's kind of like there's a constant in front of us.
yeah, if you were to do the derivative of f of x squared just by itself, that would be 2 f of x times f prime of x. Chain rule. All right, here we go. 2 f of x times f prime of x. I'm done with that one. Plus 2 g of x times g prime of x. I'm done with that one. So I think there it is. I think we're good now. So now let's fix it. Can we fix it? Yes, we can. So check it out. This that I'm circling in yellow, is that yellow? That I'm circling in yellow is going to be in the numerator. I don't know if you guys can see that, but so here we go. I didn't mean to say yellow weird, sorry. 2 f of x, I kind of said it more like yellow. 2 g of x, g prime of x. So there it is, there's my numerator. And my denominator is everything else. 2, square root f of x squared plus g of x squared. Oh, because when it's a negative half, when I brought it down, it was half, and then because I don't have anything that would bring it down. Because I have a negative exponent, so if I bring it down, it turns to a positive exponent. I have a negative 1/2. That negative 1/2, when you bring it down, turns to a positive 1/2, and then half means square root. Side note, look, miss. X to the negative 1/2 means 1 over x to the half. And then x to the half means 1 over square root of x.
Yeah, I know that. What is our so is everything in the...
Everything inside the green parenthesis, what's green? Everything inside the green parenthesis is to the negative 1/2.
Oh, okay. Oh.
Okay. All right. Make life simpler for yourself. Is there something you can cancel out? The 2's. You can factor out the 2's, which means you can cancel out every single one of those 2's. So here we go. Now we're going to evaluate it. Evaluate it at what x value? 2. So I'm going to write first f of 2, f prime of 2, all that good stuff. F of 2, f prime of 2, plus g of 2, g prime of 2, over square root f of 2 squared plus g of 2 squared. All right, you guys tell me what those numbers are. What's f of 2? 8. What's f prime of 2? 1/3. Plus, what's g of 2? 2. What's g prime of 2? -3. Over square root, and let's see if I remember. F of 2 was 8, so 8 squared, plus, and then g of 2 was 2? 2 squared. So let's see what we get. We get 8/3 minus 6 over square root 64 plus 4, 68. Are we still okay, guys? All right, here we go. I'm going to multiply that 6 by 3 over 3. So I have 8/3 minus 6, 12, 18. 18 over 3 over, now square root of 68 breaks down to 2 times square root of 17. 17 times 4. I actually typed it in my calculator here. So 17 times 4 is 68. So the square root of 4 is 2. We still okay, guys? All right. So here we go. 8 minus 18 is negative 10 over, keep change flip, or just bring the 2 square root of 17 next to the 3. 2 times 3 is, and actually that's a good answer there, but they probably want to rationalize it. So multiply by the square root of 17 over the square root of 17. So finally we get this negative 10 square root of 17 over, and then 6 times 17, 102. And I think 10 over 102 is going to reduce. Now, I make mistakes all the time, so let me know.
Can you simplify the 10 and 102?
Yes, you can. Negative 5 square root of 17 over 51. And 5 over 51 does not reduce. I don't see any mistakes. I took those numbers from you guys. F of 2 was 8. F of prime of 2 was 1/3, 2, and negative 3, all that good stuff. Yeah.
On my paper, I went sideways, and then said you were down, and I went sideways again.
Oh, it's all good. Did it all fit?
It all fit.
Yeah, mine, it's all over the place. All right, guys. So now we